Hello, my name is David Giaretta. I'm the chair of the Data Archive and Interoperability Working Group of the Consultative Committee for Space Data Systems. CCSDS is the working arm of ISO TC20 SC13, and so the documents produced by the working group have become, after both CCSDS and ISO extensive reviews, ISO standards. My co-authors are some of my fellow members of the working group, Mike Kearney, John Garrett, and Steve Hughes. The group, we have created a number of ISO standards of particular interest to digital preservation, one of which is the well-known reference model for an Open Archival Information System, OEIS. The first version was published in 2002, the second in 2012, and we're working on the third version now, so I hope it'll be out in 2022. One of the other standards is ISO 16363. So I'll just describe the outline of this talk. So what I'd like to do is, as the title suggests, is to describe OEIS and the digital preservation concepts embodied in that document, and how they should be applied to web pages in particular as digital objects, but also to all the other types of digital objects that websites give one access to, and say a few words about preparing for preservation. I'll just take my image away from there and continue. So this is when people think about or even teach about OEIS, this diagram is often the only thing they show. It's the OEIS functional model. It is very, very useful for terminology, but it's not actually specified for OEIS conformance. People who do focus only on this functional model actually have not read OEIS properly, and you should not trust them. As clearly stated in the standard, OEIS conformance is defined in terms of the OEIS information model and the mandatory responsibilities. For this talk, I need to look at the information model. This information model, I can briefly explain. The basic model shows that a data object could be either a physical object or a digital object. By itself, a data object could mean anything. What we need is something that makes it understandable and usable, what OEIS calls an information object. In order to get from a data object to an information object, one must add what Oeis calls representation information. In the case of objects such as PDF files and web pages, for example, right now we have readily available software such as Adobe PDF readers and web browsers such as Firefox. These will display characters and images on a screen which, it is normally assumed, a human will be able to understand. If this always works, and if we can be sure that it will always work, then there's no problem, except to make sure we do not lose the bits. But we all know that we must expect there will be other problems. What are we relying on? Maybe it's the medium. Vellum is a form of treated animal skin, which can be, on which, for example, the UK laws have been written for many years, and they're rolled and piled up on shelves and kept very carefully. But even if you can see the symbols, there's no guarantee that the meaning will be understandable. What are we relying on in the digital world? Let's just go through these. So for documents in word processor form, problems arise much more quickly, as we are well aware. I think everybody here is well aware of the issues arising from software availability and versioning. Let's look a little deeper. Oeis defines digital objects as a set of bit sequences, literally ones and zeros. A digital object normally encodes some information. Oeis defines information as any type of knowledge that can be exchanged. In an exchange, it is represented by data. The ones and the zeros may be on your hard disk, and so not immediately visible on the disk. But what follows applies even if the ones and zeros are printed on paper, or on microfilm, or etched onto diamond, or even carved onto stone tablets. What information do those ones and zeros mean? Well, the bit sequences here could mean anything. Maybe a PDF with a bank statement. There may be, but there may be, for example, some sort of code book which tells me that when I see this particular pattern up there, it means that launch a rocket, or go to my office and take out the document on the top shelf, or it may be used by some software on my computer to draw a line on the screen, or pretty well anything else. Right now, in many cases, we have software such as web browsers which have built-in codes that recognize these patterns and what the appropriate responses are. Alternatively, we may be taught as part of our education what this bit sequence means, or we could ask someone, perhaps the person who created the bit sequence. Will these work in the future? We all know that these things may not be available in the future because software, hardware, and what is common knowledge and who is alive will all change. let's look at some bits. What could they mean? We can rewrite this as hexadecimal, which groups 4 bits together to represent one of 16 characters. And if we do this, if we see at the beginning something that says, as you see there, Cafe Babe, then that indicates that this is the start of a Java class file. Or if it's PK something, then maybe it's a compressed file. If it's PDF something, then maybe it's a PDF file. In this case, there's nothing obvious. There are other standard encodings. The truth is that any sequence of bits could mean anything. We can guess using some standard encodings, but can we be sure? And even if we guess the right encoding, in this case ASCII, what does it mean? Well, in this case, it was my flight reference to return from a conference. Of course, there are more complex digital objects out there, and things are getting more complex over time. Digital objects, for example, they're containers for other objects. For example, the data at CERN could be printed, but it really would not be useful that way. And now, of course, the printed CERN data could be used to decorate a wall, but that's not its normal use. So normally, simply being able to print numbers or text of, for example, scientific data is not enough. And we'll come to what that means shortly. Some more things, in particular websites. And of course, any of these things can be obtained through a website. What Oeis talks about is information. It can be many things. Data can be it can be just about anything, but then are we talking about just the bits of some data? Are we talking about look and feel or behavior? For example, the bits could be a software program, even MS Word. How it behaves is clearly important. Is performance important? Does it matter how quickly something happens? Maybe we need to consider things at different levels of some kind. Explicit, maybe perhaps the obvious things. Implicit, maybe the internals that happen behind the scenes. Or tacit, things that need something that I already know in order to make sense. For example, some concept that an astronomer would just refer to by name, but somebody who's not an astronomer might not understand. So OEIS gives us a way to test whether preservation is successful, basically. Can the information encoded in the bits be understood or used in some way. But of course that comes to the question, understood by whom? OEIS provides a subtle answer, and that involves the designated community, which the repository must decide on and make clear. Of course, understanding could be quite complex. What does this image mean? Does one need to have read the Da Vinci Code to understand it? What about these objects? Perhaps something that has not yet been decoded or understood, but is the object of research. This rather interesting image, it's a colorized version of something that was sent into space as a signal. It was meant to be used to communicate with extraterrestrials. It was meant to be understood by non-humans, given that they know about mathematics and physics and astronomy. Maybe we will know in the future when they come, if and when they come to visit, whether this was successful. By the way, I believe that when this was given to a group of scientists on Earth, they could not decipher it. How about this? Obviously a table. It could be encoded as a comma-separated value file, a CSV file, in ASCII or Unicode. One might guess what the columns mean, but what does it actually mean? The right-hand symbols look like a date and a time, but what time zone? What about the rest? Guessing is surely not ideal. The representation information must make these clear. Here's some. How much more? Come back to the question, what does understand and use require? What should the members of the designated community need to be able to do? The updates to OEIS include the important idea of preservation objectives, which allow the repository to make to be explicit about what they mean. So I hope you can understand now why OEIS puts such stress on the information model and representation information. OEIS identifies some important categories of representation information. Structure representation information, for example, formats. Semantic representation information, for example, dictionaries which define the language or special words. And then other representation information, a catch-all for anything else that a user may need to understand the data object, including software. So how does this apply to me, you might be thinking? For simple things like a Word file, one can say that the structure representation information is, this is a Word file. The other representation information is, we need the word application. But the semantics is usually forgotten. But what about other types of digital objects? Looking at something which is likely to be less familiar to you, FITS is a format which is widely used in astronomy and elsewhere. The digital object here is a FITS file, as you can see, and you can see some examples of the different types of representation information. So structure, perhaps a PDF, describes the FITS standard, which defines the format. A dictionary may be encoded in XML, explaining the semantics of the header keywords, and some software to display and manipulate the FITS file. By the way, this does not just apply to astronomy. Scans of ancient Vatican documents have been encoded and archived, not as JPEGs or TIFFs, but as FITS files, because it was felt that these were more likely to be preservable. What makes the OEIS information model so powerful is that most things are information encoded as data, either physical or digital. But this also applies to representation information. It is an information object, which means we can draw the same diagram with different objects, obviously, to ensure that the representation information is understandable and usable. And one can continue this on. Another useful concept introduced by OEIS is that of information packaging. This diagram is a little different from that in the current version of OEIS. Instead, this shows the more general diagram, which is in the updated version of OEIS undergoing review right now. The point is that one needs to package things together. The packaging information tells us how to unpack the bits that we receive. For example, if a zip file has a manifest file in it which lists and explains what all the other files are, the packaging information tells us that this is a zip file, which when unzipped will reveal a manifest file which lists and explains the other files. The package itself is described by a package description. So one might think in terms of Baggett files and so forth. They can be interpreted in this way. The OEIS archival information package is a logical package that brings together everything needed to preserve the content information, the thing that's being preserved. The term logical package means that this does not require everything to be in a single file, such as a zip file. Instead, it would be, for example, a collection of pointers to many separate objects. This identifies that one needs the data object, its representation information. The question is how much representation information is needed. The answer OEIS provides is that the archive defines a designated community which the archive guarantees to be able to understand the information and will provide enough information for that enough representation information for that designated community. It also has things like provenance. How much provenance? The answer is enough so that one may be able to make a judgment about the degree of authenticity of the object. And things like context, reference, fixity and access rights, which OEIS defines, but I'm not going to go into here. Now, finally, coming to web pages from the and websites from the point of view of Oeis. Web servers send our browser streams of bits, actually lots of packets or packages of bits. The hardware and software of the internet arranges to get these packets to our computer. Our computer software is ready to display the data that comes to it, normally on port 80, using our favorite web browser. The web browser has various configuration settings, normally done without our being aware of it, so that if it receives, say, a Word file, then MS Word will be started and the appropriate bits will be sent to the application, which will then display the document. But HTML has changed over the years. Not all websites use the latest and greatest version of HTML, and not all web browsers support all capabilities of HTML or CSS, etc. Some websites have invalid or incomplete HTML. Websites can display essentially any character from any language, thanks to Unicode. However, some web pages have mistakes. Many browsers work around these errors, perhaps by making best guesses at what was really meant by the web page creator. Web pages contain information about the files, such as Word, in terms of media types, previously called MIME types, as a hint about how to display the files. But quotes application/MS Word does not tell us the version of Word being used. In any archive, if I were to give you a Word file to preserve, you would want to analyze the version of Word and do lots of other tests and checks. Are these all done if the Word file comes via a web page? And what about quotes application/octet-stream? It tells one essentially nothing, and all one can do is to save the file. WARC is an ISO standard that you're familiar with. It essentially captures the bytes that come into a web browser from various web servers and adds some metadata. Actually, that's not a term I like, because it could mean anything. But we can look at some examples. Here's an example of an uncompressed WARC file. You can look at the details later, and continues down. But not all browsers implement every aspect of CSS. What do some of these things mean? Keywords are present but not defined, although clearly we might guess some. Does the European Union referred to here include the UK now? I'm not sure. What does, in quotes, OG colon, close quotes, mean? Not sure. If we are really to preserve a web page, then WARC does an essential job, but it does not do everything needed. We can be guided by the Oeis information model. Here are some examples of additional information that needs to be captured for preservation. We know what is needed to preserve digitally encoded information, namely the things in an archival information package, an AIP. This slide lists the components of an AIP and compares them to what is in a WARC file. One can see that a lot is missing. but WARC can play an important role. We just need to make sure these extra things are added somehow, either in the WARC file or associated with the WARC file. Database is interesting also. Often in content management systems, the database drives the website. These databases may be fairly simple. They may be quite complex with lots of interrelated tables, built-in procedures and triggers. May have software plus data. One can use the SCIARD2 to preserve databases, but we should be aware of the limitations. And I'll leave you to look at these things later. But all of these things are things which one probably needs something more than SCIARD would contain, just as the WARC file. And we can think back to the definition of an archival information package and supplement all the supplement what these data files, namely the database, the SCIARD file or the WARC file has, in order to properly preserve the information that they are supposed to help preserve. I'm going to move on slightly to think about the family of standards which my colleagues and I have written. We have, of course, Oeis. We have a way to check that preservation is being done properly. We have standards describing a way, in a general way, how to transfer information to an archive from a producer. We have standards for creating certain types of representation information. And we're also working on how to make sure all the information needed for preservation is collected. IPELCU stands for Information Preparation to ensure long-term usability. IPELCU identifies many types of information which should, if possible, be collected while it is being created. Many of these are immediately recognized from the OEIS information model, but there are many other topics. And the important thing to remember is that these objects, for example, in research projects, may be complex and happen over many stages. Large projects may involve many different teams of people, many different phases, where each phase there's some initiation, planning, executing those plans, and then closing it off, moving on to the next phase. Of course, in simple projects, this may be regarded as a complete overkill, but many things tend to be forgotten. So we've modeled IPELCU on two very interesting documents, PMBOK, the Project Management Body of Knowledge, and DMBOK, Data Management Body of Knowledge, in order to create checklists so that as information is created in projects large and small, then we, the people who look after archives and are asked to preserve objects, will have enough information. in order to preserve those objects. And I hope I've given you some examples of the sorts of information that needs to be captured. So I'll close now by saying that if all you will ever do is to preserve very simple documents and websites, then this presentation may have been a waste of your time, and I apologize. However, I hope that this presentation has challenged some of your set ideas and practices and will make you think and ask questions when you are challenged to preserve other digital objects. I believe that the concepts of OEIS provide a solid basis for such challenges, but clearly we've not been able to discuss all the subtleties of the OEIS reference model. However, a warning, there are many misleading and/or incomplete guides out there. Question everything you're told about preservation by software salespeople, teachers and managers, and even me. So with that, thank you, and I'm open for any questions.